All right, functions, today we talked about how to solve for a triangle. So to solve for a triangle means that you are going to find all the missing parts. That means you're going to find any missing side lengths, any missing angles. You might not be given everything, but you're going to be given some information. So when you're solving a triangle, draw a sketch. It usually helps me to draw a picture right away. We've been practicing this. You can use A, B, and C. Typically when we use A, B, and C, the side length A, we're going to use lowercase letters for the side lengths, and we'll use, it doesn't really matter, but C is usually reserved for that 90 degrees because the hypotenuse is usually going to be C. So you don't need to write this down. This is just something that we're going to talk about. So when I give you a triangle, we're going to solve for all missing pieces. So we're going to use what we know to help us solve for those unknowns. We are going to be using sine, cosine, and tangent. Just those three. So SOHCA, TOA. Those things are going to help us solve for different things. We will be using the sine of a given angle. So that's why it says theta degrees, cosine theta degrees, tangent theta degrees. We'll be using a given angle to solve, and we use that when we're given an angle and a side length. So we're going to be able to use those ratios to help us solve for that unknown side length. We will be using something that we haven't seen before. So we will use the inverse of sine, or the inverse of cosine, or the inverse of tangent to solve for unknown angles. Typically we'll be given two side lengths and a 90 degrees. That'll be the only thing that we're given. So we'll use the opposite over the hypotenuse, those side lengths. We're going to plug those into our calculators and we're going to get that information. So the first thing I need you to do is get your calculator out. I need you to go into mode. So let me turn it on. Go to mode, and you're going to go down 2 spaces right there where it says radians and degrees, and make sure I can't see what I'm doing that way. Make sure radian is highlighted like that, so that what you'll do is you'll get it to where it's blinking, you'll hit enter. Once you hit enter there, you can go to second mode, and that'll get you out of that screen. Okay, so now that we're all on degrees, and to make sure as we go forward, we'll have the answers on there, and if you are not getting the same answers but you're typing everything incorrectly, just let me know. Come into class and talk to me and I'll fix your calculator for you. Okay, so we're going to be using the inverse when we're given side lengths but not an angle other than 90 degrees. So we are going to practice this. So I would like you to get this triangle in your notes. As you're drawing that triangle, I wanted to talk about what we round to. So typically I have students asking me, I don't know how far to round, what do I round to? So in this problem, we have 34 degrees and then we have 12.7. So 12.7, that means that all of our answers, we're going to round to that first decimal place, to the 10th place, because we want to match what the rounding was done in the problem. Okay, so the first thing we're going to do is identify different things. We are given what? We have the hypotenuse, and we're given angle A. We probably can find angle B pretty quickly because we have a 90 degrees and 34 degrees, and the sum of the interior angles of a triangle always 180. So we end up with what, 56? Yeah. So we can find that right away pretty quickly. That's going to be 56 degrees. But we're going to just try to use what is given to us. So I have angle A and the hypotenuse. So if I were to want to find side length A, so lowercase a, then I'm going to use what? So that would be opposite over hypotenuse. Which of the three trig functions use opposite over hypotenuse? Sine, right? So we are going to use the sine of angle A because we are trying to find side length A, but I know side length C. So I also know angle A. So I'm going to plug in the things that I do know. So I'm going to plug in the 34 degrees. And then to solve for this, we multiply. To get that A by itself, we're going to multiply both sides by 12.7. on both sides. So we get 12.7. So in your calculator, what you're going to type is exactly what you see on my screen. You're going to type 2.7 times sine. Now your sine button is right above the comma button, above the 7. See? Sine. Right there. Sine. So you're going to type sine, and you're going to type 34. You don't have to worry about the degrees because that's why we went into mode. We put it in degrees. So it knows that that is 34 degrees. And then we're going to hit enter. And I got 7.101749874. But I only have to round to the 10th place. So 7.1 inches. So now I know that A is actually equal to 7.1 inches. All right. Now, we said at the beginning that we want to use the given information to find any of the missing stuff. So now I want to find side length B. And again, it's not really equal because we rounded. So we're going to find side length B. So if I have the hypotenuse, side length B is the adjacent side to 34 degrees. So what goes with adjacent? That's going to be cosine. So the cosine of angle A is going to be equal to B over C. Again, I know what angle A is, and I know what my hypotenuse is, so I'm going to plug those in. I'm going to multiply both sides by 12.7, and I'm going to type in my calculator 12.7 times the cosine of 34 degrees. That's going to be about 10.5 inches. Okay, so now I have that. I've got 10.5 inches. Now, we already found this measurement, but we did that by doing B is going to be equal to 90 degrees minus A. 90 minus 34 is 56. So now I have every piece. I know all of the parts of this triangle. This triangle is totally solved. So this slide right here says, yeah, we could have started off with the measurement of B and then used the trigonometric functions of B to find the unknown sides. We totally could have done that. I said that at the beginning, right? I know it's going to be 56 degrees. So if I know that, that's okay. The process of solving means that some of us are going to start in different places, and that's totally okay. And that's actually what's super fun about solving for triangles, is we're all going to get the same answers, but we might do it a little bit differently. But one of the most main things that I want you to take away from this is that try to use the given information rather than using information that you found. You are rounding, you may have gotten the wrong answer. There's a lot of different reasons why you want to use the given information. So if it's possible, you should. Okay, so let's try this one. This one we're given 2 side lengths. So go ahead and get this triangle in your notes. Go ahead and hit pause here so you can get that, because I'm going to move on. Okay, so I assumed, because we're comfortable with it, we have a missing side length. We are using a right triangle. Most of us jump to using the Pythagorean theorem. So a squared plus b squared equals c squared. We are solving for b squared. So b squared, if we did all the solving, would be b squared is equal to c squared minus a squared. So then we end up with plugging those two things in since we know what they are. And we end up with 2004.6915. So we're going to get some rounding in here, right? And we end up with about 44.77. So notice that I didn't round in the square root right here. I went 4 decimal places right there. So because I went 4 decimal places right there, I waited to round until I got to the very, very end. Okay, so now the next thing we want to do, we want to use our givens. So I'm going to want to say that we're going to find angle A. So angle A is right here. So we're looking for an unknown angle. This is where we have to decide which inverse do we want to use. So I've got the opposite and the hypotenuse. The opposite side and the hypotenuse, well, that's going to be sine. So I'm going to use the inverse of sine to get that angle. So because I know that angle A, or the sine of A, is going to be equal to its opposite over hypotenuse, I'm going to use that inverse side. So the way you do that on your calculator is you do second, which is the blue button, second, and then you're going to hit sine, and you should get sine, the inverse of sine. And then you just type 29.43 divided by 53.58. You close that parenthesis, you hit enter, and I get 33.3170944. Okay, well, I've got the answer. So then I need to round to the second decimal place, so I'm going to get 33.32. Be careful with your rounding because it says 0.317. The 7 tells me that I need to round that one up to 2. Okay, so now I know what angle A is. Angle A is 33.32. We're going to go ahead and use, went too far. To find angle B, I've got the adjacent side and the hypotenuse. So adjacent over hypotenuse, that's going to be cosine. So we're going to use the inverse of cosine, which is adjacent over hypotenuse, which is basically the same ratio, only we're going to use the inverse of cosine. So that's going to be inverse cosine, which is right next to the sine. And we're going to type 29.43 divided by 53.58. Close that parenthesis, and I get 56.682905856, or 56.68. Okay, some of you might have just done 90 degrees minus the 33.32, and that's going to be equal to the same thing. Again, we could end up with a rounding error doing it that way, but it worked out okay this time. Okay, so that was the last example I went over today. We are going to be doing more examples tomorrow. As we go, we will be continuing to just solve. We'll be solving with word problems, which are just, doing these kind of problems in context, which I think is somewhat easier. It makes more sense to me to do this type of problem solving. But this is something that you actually may use in the real world if you do any gardening or building anything really. Okay, I actually used this when I was tiling my fireplace with my husband. We had a little piece of a right triangle, and we needed to cut it, and we needed to figure out what the diagonal was, and I actually used the Pythagorean theorem to figure it out. We needed the angle that we needed to cut it at, so we used that as well. We had the length, but we needed the angle because of the type of saw we were using. So that was pretty cool. My husband was like, hey, this is what you do. Go figure it out. So pretty cool. All right, I hope you all have a great day. If you have any questions, please come into class with those questions. See you all tomorrow.